Hi, welcome to another episode of Proof Pilot. We're still talking about topology and we have reached the gluing lemma. As the name of it sounds, it literally is gluing two spaces if under some conditions. So let me just read this thing, and do not forget to hit the subscribe button and like the video if you like it. If there's any questions about the subject, I will gladly answer to them in the comment section. Let X and Y be a topological space, and let these be either an arbitrary open cover of X or a finite closed cover of X. Suppose that we are given continuous maps Fi that agree on overlaps. So on the overlaps, these functions are equal. Then there exists a unique continuous map whose restriction to each of these sets, each of these covers, is equal to Fi. So let me just show you what this thing really means. So let's suppose that we have a cover, and it doesn't matter if it's an infinite open cover or it's a finite closed cover. Imagine that we have a cover on our space and there is another space. If there exists a function from each of these sets, then so let's suppose that there is a function for each of these sets. Okay, so this function maps our set to a set here, and this function maps our set to here, and they both agree on intersections. Then I can say that there exists a continuous function which the restriction to each of these sets is equal to Fi. The way we are going to prove this is by a criterion that we knew from continuity. And I'm going to show you, this is just a reminder, we have talked about this. So what's that criterion? It's a local criterion for continuity. So if you have a map and that map is continuous, then this is an if and only if, okay? It's a two-way statement. Each point of your topological space has a neighborhood which the restriction of f is continuous. Okay, so when we say have a neighborhood, we're talking about open sets. So the part that we are here talking about that talks about infinite open sets, okay, so if it's a cover and it's an open cover, then the number of open sets are infinite. The gluing lemma is going to be true by elementary set theory, by this criterion. But if we have closed cover, which the number of sets are finite, then we have to prove it by bare hands. So I'm going to prove this for the finite closed cover case. Okay, so I want to show that for each closed set that I take in my topological space Y, let's name them U, then the inverse image will be open, will be closed. Because this is a closed set, then the inverse image should be closed. So what is this F exactly? Well, we define this F because we have a finite closed cover. We can just define this F for each section, okay, to be that Fi that we had in our hypothesis. So that's how we define F. And now I have just to prove that this F is closed. The inverse image of a closed set is closed, which means that this F is continuous. So if I take the inverse image of my U, this is going to be just some closed set in AI, is some AI, or potentially the union of some closed set in some AI, but we can just see them individually. So this is going to be a closed set in AI. And as we knew AI is going to be a closed set. Okay, this is by hypothesis a closed set of X, and by property we know this is like the transitive property. So the F inverse of a closed set is going to be closed in X. Okay, this is by the transitive property. So that's the gluing lemma. I hope you have enjoyed this video. Do not forget to like and subscribe.